Hi my dear friends, welcome back to our render setup workshop. This is the sixth session of our workshop, and in this one we're going to be focusing on image sampler. But before we start talking about that, let me just do a quick recap. In the previous session and so far we've learned about GI, and we've learned what we need to do for both our test renders and also the final renders. So let's review quickly. For a quick final render, we use Irradiance Map for primary engine, Light Cache for secondary. We put the preset on medium or high, and also subdivisions on 80. Now for Light Cache, we put the subdivisions of 2000, for example. This will give a very quick but high quality final render, and don't forget about the dimensions. You can use anything above 3000. Now for our test renders, we keep the engines the same, preset on very low, subdivisions on 20, and Light Cache subdivisions on 200. This will give us a very quick render that we can just use and study to make our scenes better. Now let me tell you something really interesting that could just save you a lot of time. So you need these two types of renders quite often. So why not just save them as presets? So what you can do is that, all these settings for the test render, you can just come up here and save the preset here. You can just click on save preset, choose a name for it, and let's say test, and save it. And you can just, it asks you whether you want to save all of these items, and you click on save, and that's it. Now every time you need to take a test render, you can just come here and use the setting readily available for you. Just select it and just use it. And loading it is pretty simple too. You go to presets and just select the one that you want and just load it. Okay, so it's very easy to do. You can just export it out of 3ds Max and use it on another computer as well. And if you want to, you can just make another preset with your final render setting and just keep them both on your PC, and just it could save you a lot of time. Alright, we talked about the GI tab a lot. Let's just go back to the V-Ray tab and focus on image sampler, which is one of the most important parts of the V-Ray tab. So let's just start talking about the image sampler. What does it do? What does it manage? Now in the previous sessions we said that every time that we click on render, the first thing that happens is that we have some GI calculations. Okay, so the GI calculations start. We have a couple of passes that are dedicated to that, and after that our render or image is starting to be displayed to us. Now I say it start to be displayed because it's a process, and we can choose how that process unfolds. So the way that the image of the render is displayed to us can be changed in terms of the methods that have been used for that process, or the quality, or the time. So let me just take a quick render and tell you what I mean. So the first thing that happens, as you can see, is the GI calculations, and then with a few of these pre-passes being completed, we start seeing some parts of the actual final image or render be displayed to us. But it hasn't happened yet. Right now you can see that the buckets are just processing the image, collecting information, and we have a couple of passes of this happening before we can see parts of our actual image. You can see that it's just taking its time when it's dealing with this area, because this area is a very complicated one. It's a plant with a lot of leaves, and it's a complicated image here. So it's a complicated or complex object, and that's why it's taking a long time trying to collect some data from this area and just process it before we can see parts of this plant here. Okay, so the setting that we have chosen for our image sampler section is basically in charge of what's happening right now, and we have yet to see a part of our final image. Okay, so it's starting to happen now, and you can see image sampler at work, and as time passes we will see our final image improve in quality and also in resolution. And that's basically what the process of rendering entails. It's time to go back to our image sampler and start talking about some of the items that we have here. The first one is the two methods that we have. One of them is called bucket, the other is progressive, and these two methods show our final image differently. Now what do I mean by that? I'm going to show you with an example. So I'm going to put it on bucket for now, and what is going to happen after I take a render is that after a couple of passes have been completed, we're going to start seeing the final image one bucket at a time. So it's gonna complete the final image and show us pieces of the final render through these buckets. Okay, So with the bucket method chosen, the square or the bucket is a unit through which we're going to see pieces of our final render. Alright, we're going to test out both of these methods. We're going to start with bucket like I said, and I'm going to go back to GI, and I'm not going to change any setting with the GI. Let's just take a render and try to notice the point from which the buckets start to appear and show pieces of our final image. Right now the buckets are just moving and they're just collecting data, lighting data, material data, and after a couple of these pre-passes have been completed and they have collected enough data from the scene, we're going to see these buckets show us a completed piece of our final render. Okay, so it hasn't happened yet. I'm gonna be able to pay attention to when it starts to happen, and we're gonna see it together. And based on the amount of CPU cores that you have and the operating system that you are working with, the speed of these buckets moving could be different. So I'm going to tell you about that later on as well. Let's just wait for one of these buckets to start showing us a piece of our final render. Let's see. Okay, I think we are approaching that moment. There, see these buckets? These are pieces of our final image that are being shown to us piece by piece, like a puzzle almost, where the pieces are just in the shape of these buckets or squares. Okay, so this one hasn't been completely processed, but in a couple of seconds it's going to show us there that completed horse figurine. Okay, so this is what the bucket method achieves for us. Let's choose the other one, which is called progressive, and see how that works. So basically, if we take a render with the progressive type, you can see that after the first two passes, which are like pre-passes, have been completed and the GI information has been collected and all the calculations have been made, then the V-Ray engine is going to start displaying our final image progressively. So it's going to start with a very low resolution final image, and as time passes it's going to improve that image in terms of resolution and quality. So it's going to start with a lot of noise like this, and then as time passes we're going to see a much better final image in terms of quality. So what's the difference between these two methods really, other than what you just witnessed, is that if you have enough time there's no difference. But if you want to take test renders and you don't care about the noise because you know the noise is going to go away if you give it enough time, then the progressive method would be a better choice for that, because you're going to be able to see your image a lot faster, and then you can just make decisions and change the scene. So for test renders we always put this on progressive because it suits our purpose. But if you have enough time, it's not going to be any difference in quality whether you choose bucket or progressive. So for this scene, let's say you have 2 hours, and it doesn't really matter which method you choose because at the end they're going to give you identical results. Alright, it's too soon to do a save preset just yet. Wait for more information to absorb and then you can just save your presets. Now let's start talking about something else. We talked about the bucket and the progressive methods. Let's move down to the lower section. Now these parameters under type are not that important to us right now. Let's move down. We have minimum subdivisions and also maximum subdivisions. So what do they do? Let me just recap what Image Sampler does first. So Image Sampler is responsible for all the calculations and all the data collection that is required for transforming our 3D scene into a 2D render image. Okay, so Image Sampler does all of that. Now if we go into our scene, there are places in the scene which are more complicated than other places. For example, we have the collision of different colors and shapes, maybe here. Okay, so we have different pixelated colors, different shapes, and this area is a lot more complicated than the green wall that we have in the other parts of our image. Okay, so this area here needs more calculations, needs more data collection, and with that minimum and maximum subdivision we can determine how many data samples we need collected from these areas. So this area from our scene, the wall, does not really need much sample collection because it's a fairly simple area. We don't have that many colors or shapes, but this area in the plant, the leaves, or this piece of the furniture is a fairly complex area in terms of colors and also shapes. So if I put the minimum subdivisions on 1 in areas of my scene like this green wall here that are really simple, one sample will just suffice and one sample will be collected and that will be used to do the calculations. But in other areas like this one, which is more complicated, I will have more than one sample and up to 100 samples taken so that the V-Ray engine has enough data to process and render my image. Now what happens if I put the max subdivisions on 1? Now, regardless of how complicated the part of my scene is, one sample will be collected at all times in all the parts, and I'm going to have a very quick render which is going to be pixelated and not high quality at all. Let's just do that together. So I'm going to click on render, and let's just notice how long it takes for that to finish. And we're going to see, so 57 seconds, pretty fast, but you can see the results. It's very pixelated, it's very noisy. We cannot see the colors or the shapes of objects in our scenes clearly, and overall it's not a very good render at all. So this is what happens when you put the minimum subdivision and max subdivisions on 1. But if I put 100 for maximum and take another render, this time it's gonna take noticeably a longer time, but the quality obviously is gonna improve immensely. So let's just take that render together and see how long that takes and check out the quality. Then we're going to compare. So I know it's gonna take a long time, but don't worry, I'm gonna fast forward the video. So let's see how much this one takes. I'm gonna click on render and I'm gonna come back to the render. So it took 43 minutes, this one. And the changes in terms of quality is very noticeable. You can see that we can clearly see the shapes, the colors, and we have a lot better quality. Now you can just see the A and B version. So the one on the left is 100 max subdivisions and the one on the right is 1. Okay, so what happens if we put like 20, a smaller number for max subdivisions? Are we gonna experience a lot lower quality, or is that gonna be enough? Let's just find out. I'm gonna put 20 for max subdivisions, and I'm gonna take another render, and let's see how much this one takes, and let's compare the quality with 100 max subdivisions. So I'm gonna click on render, and let's see when this one finishes. So this one's gonna take a lot less. So it took 15 minutes, this one. So let's just compare. The one on the left, or A, is the one that we just took with 20 max subdivisions, and the one on the right, or B, is the one that we took and it had 100 max subdivisions. So in an area like this, which is very simple, we're not gonna experience that much of a difference in terms of quality, and you can see that the differences are not that noticeable. So 20 is a good enough number for areas like this, and maybe even this part. Okay, so let's see. The differences are very minimal. See, we can see the differences, but not that much. But what happens in this area here? Here it's a very complicated area. We have caustics, we have refractions, reflections, and you can see the differences more visibly here. So now we can assume that processing an area like this would require more subdivisions than 20. For example, let's say 60 or 80, and that's why we have a higher quality with the one that had 100 max subdivisions. So I suggest that you use a max subdivision of 5 for your test renders and 100 for your final renders. Okay, so this is how you can just work with these numbers. If you put this on bucket, you get the same thing. So we have still minimum subdivisions and max subdivisions, but it's the same story. And since it works this exact same way, we're not gonna get into it, and we're not gonna talk about it because it's basically the same thing. So let's just move on. So if I put the type back on progressive, we have this other option called max render time, which is calculated in minutes. Right now it's at 0, and 0 means that we do not have any time limitations when taking renders. So let me tell you something. If I put the max subdivisions at 100 but put a max render time limit of 1 minute, what happens? So we can just try that out because it's not gonna take that long. I'm gonna impose a max render time of 1 minute. So I'm gonna put in 1 here, and we have max subdivisions of 100. Okay, remember it took 43 minutes the last time that we used that 100 max subdivisions. So now that V-Ray has only 1 minute, it's not gonna reach 100 max subdivisions. It's probably gonna reach 5 or 10 because it has to finish the render in 1 minute. Okay, so let's just check out the render for ourselves. 1 minute has passed and this is what we get. See, the render is kind of noisy and not high quality at all, and it's because it could not reach 100 max subdivisions because of the time limit that we imposed on it. So it probably reached like 2 or 3 or maybe 5 max subdivisions for that render to finish. Okay, so this is how we can impose a time limit if we needed to, but I don't usually do it this way. I usually put it on 0 with no time limitations, and even if I want to take a test render, I just use 5 for my max subdivisions. Okay, so let me just put 100 back in there. Let's move on to the next item in our setting, which is called noise threshold. And with this parameter, we can just determine how tolerant the V-Ray engine is regarding the noises that we have in our renders, or how precisely it works to reduce the amount of noise that we have in our renders. So if we use a big number here, let's say 100, even with the max subdivisions of 100, if we take a render, you can see that this time it's going to take a notably shorter time to finish the render, and we're going to have some noise in the render, which is going to be very visible. Okay, so we can just check out the parameters that we chose. The render type is progressive. We have 100 as max subdivisions. We have no render time limitations, and the noise threshold is at 100. Okay, the render has finished, and you can see that we still have a lot of noise in the render. Okay, so it's not the same render that we had a couple of minutes ago with the same setting, but with a smaller noise threshold. And this amount of noise is not, generally acceptable for final renders, so we need to lower this noise threshold number to a very small number, like 0.001. This is gonna improve the quality immensely, but it's gonna take a longer time, obviously. But we're going to get rid of all of this noise that we see in this render here. Okay, so let's just recap what we learned here. For our test renders, for max subdivisions, I usually put a number like 10, for example, because it gets the job done really quickly. And also for the noise threshold, I put 10, and this setting, the numbers that I just put in, would just give me a very good result for my testing purposes, and I could just look at that test render very quickly and decide what to change about my scene. So a lot of people use weird numbers here because they don't really understand these parameters. For example, they use 100 for their max subdivisions, but they also use a very big number for their noise threshold, and they expect to have a nice quality render. And it's because they don't really understand these parameters and how they work. That's why they don't really use numbers that work well with each other and are kind of harmonious, and they kind of use numbers that are like work in opposites. And that's why I always insist on learning the image sampler, and especially these parameters that are really helpful for our work. And I use different comparisons and testing out different numbers so that you can just understand how they work together. By the way, I'm using a mid-tier laptop, and that's why it's taking this long for some of the renders to finish. I used to have my tutorials recorded on a powerful PC, but a lot of you objected that it wouldn't be similar to the types of laptops or PCs that you are using, and that's why I made the switch. So this is the test render that we just took. Let me change the type back to bucket, and you can see that we still have the noise threshold. Again, it's the same concept, so it requires no further explanation. We also have bucket width with a default value. Now, theoretically, you can just decrease the size of the bucket width and have a higher quality. However, I don't really recommend doing that, and I just suggest that you just keep the same default value that you have been given, and they will just work fine. The next item that we have here is called render mask, and here we can just decide what area of our scene to be rendered. If I put it on selected and select this chair here or piece of furniture, let's just select the object here. So right now, if I click on render, only this chair or piece of furniture will be rendered, and the rest of the scene will just remain unrendered or the same as it was before. Okay, so let's just wait a couple of seconds and see the results. Only this piece of furniture or chair will just be rendered. Okay, so you can see that it starts rendering, and only our chair is being rendered, and the rest of the scene remains unaffected. Okay, so as you can see, the chair has a nice quality, but the rest of the scene is still noisy and unchanged. Okay, so if you look at this glass part or the other parts of the scene, everything is unchanged. So with the same render mask of selected, I'm gonna choose this table object here. So I select it first, and then I click on render, and it's gonna render only that table that I just selected. So right now the render mask mode is unselected, and I only selected this table here to be rendered. Okay, so in a couple of seconds we're gonna notice the changes in this part, and the table, see, the table has been rendered, but the rest of the scene and the rest of the objects remain unchanged. Now we have other render mask modes. We have texture, we have layers, and we can just work with different items, but I usually put it on none because I want the whole scene to be rendered. However, you can just do different things. You can just put it on included or other options like textures, and you can just select different objects or items and add a list of items that you want to be rendered, or exclude a list of items that you don't want to be rendered. And using those lists, you can just take multiple renders, and you can just add items to be included in that list or excluded from that list, and that's how basically that works. Alright, so here we can conclude the image sampler session, and we talked about a lot of these features and options that we have here. I did not talk about all of them. There are some features left, and in the next videos from the series, if we had any use case for those features, I will certainly mention and explain them as well. Now I think after this session you have enough information to take your own test renders and final renders, and you can just start practicing with these parameters that you learned until you feel very comfortable using them. And one last thing before I finish is that for my test renders, I usually use this teapot with a green triangle on it to take an interactive render, and that very quickly gives me a very low quality render that just lets me know how the lighting or the material in my scene looks and where I need to apply some changes. Okay, so in the future videos I will talk about interactive renders and this IPR options tab in detail. I hope that you enjoyed this video, and I will see you in the next one.